On problem number 5, we're given the information about the amount of solid waste in a landfill over time. They tell us about the landfill. They say in 2010 there were 1,400 tons of waste. They tell us that the function W, the amount of waste in the landfill, is increasing. And they give us a differential equation, which is going to model the amount of waste in the landfill for the next 20 years. Now in part A, they ask us to use the equation of a tangent line to approximate the amount of waste in the landfill at time t equals 1/4, which is 3 months after the start of 2010. Remember, 3 months is 1/4 of a year. So let's think about it. It's given to us that at time t equals 0, W equals 1,400. That's like the coordinates of an ordered pair. So we can start our tangent line. Y minus 1,400 equals blank times x minus 0. Now you could think of this as W minus 1,400 equals blank times t minus 0. And that's fine too. It's very practical. We're just used to thinking in terms of x's and y's for tangent lines. Now we need to find the slope of this function. So what we need to do is find the slope. We'll use the differential equation, which is the derivative. dw dt equals 1/25 times the quantity W minus 300. So we know for a fact that we can evaluate this when t equals 0, which is to mean W equals 1,400. So we say 1/25 times 1,400 minus 300. Let's see, 1,400 minus 300 is 1,100. Divided by 25, that's going to be 44. So the slope of our tangent line is going to be 44. Here's the tangent line. Now let's get to work. Let's evaluate this tangent line when x is 1/4. So we're going to have y minus 1,400 equals 44 times 1/4 minus 0, which is 1/4. Well, 1/4 of 44 is 11. We're running out of room, so let's slide down here. Y minus 1,400 equals 11. So we'll add 1,400 to both sides, and y will equal 1,411. So after 3 months, in 2010, there will be about 1,411 tons of waste in the landfill. If you think about it, in 3 months, 11 tons of waste were added. It's a lot of waste. Okay, now let's go to part B. Part B, see what they're asking us. They're asking us to find the second derivative of W with respect to T, and then use this to determine if our estimate in part A was an underestimate or an overestimate. So let's first by finding the second derivative. Let's just review what the first derivative was. dW dt, it was 1/25 times the quantity W minus 300. Okay. So now the second derivative of W with respect to T is going to be, see, 1/25, that's a constant. Now we need to multiply by the derivative of W minus 300, which is going to be just 1 minus 300. Well, let me rephrase that. The derivative of W with respect to T is dW dt, and the derivative of 300 is 0. So here we go. Remember, dW dt was given to us, so we could say that this second derivative of W with respect to T is 1/25 of dW dt, which was 1/25 of W, the quantity W minus 300. Okay? Now, let's see. We evaluated this one, t equals 1/4. And W was 1,411. All right. So let's see here. 1,400, let's put 1,411 in for W. We're going to get 1/625 times 1,411 minus 300. Let's see, that's going to be 1111. That's kind of cool. Over 625, which is positive. Since our second derivative is positive, we know that the graph of our function is concave up. Therefore, any tangent line approximation would be an underestimate. So we'll say 1,411 tons is an underestimate. Oops. Okay, there we go. Oh, we're supposed to justify our thoughts, aren't we? Well, we'll say because the second derivative of W with respect to time is positive. At t equals 1/4, W equals 1411. That'll do it. Now moving on to part C. A lot of people thought part A and B were confusing by the way they were worded. Part C is one we have a chance to get a lot of points in.